Good morning, everyone from everywhere, or good morning, or good evening, good afternoon, wherever you're from. Welcome to this webinar on the Trimble RealWorks inspection tools. Really excited to host this webinar today. As you might know, Trimble RealWorks is quite a powerful piece of software to work with point clouds, and we incorporated quite a number of different inspection tools. And Stephen Witter will walk us through these tools and talk more about that. So I'll quickly hand it over to Stephen.
Yeah, thanks, Roland. Good morning, good afternoon to everyone around the world. Welcome to our Trimble RealWorks inspection tools session. Hopefully I can provide you a few more details, what kind of features are available in our Trimble RealWorks office software. Let's jump in our presentation. A few words about me. So I had done a professional education as a land surveyor. I had done my bachelor degree in surveying in geoinformatics, and I joined Trimble in 2010. Recently, I joined Ronald's team for the technical sales. Really looking forward to that, what the new role will provide me. And yeah, let's get started. What are the learning objectives today? We will briefly touch the licensing edition, so what kind of license you need for all these inspection tools. And then going further to the inspection map, giving you a few examples about twin surface inspection, surface to model inspection, and a quite important feature would be the inspection map analyzer. There we have different options available to analyze these data sets. Then as the next topic would be the floor inspection and the floor flatness and floor levelness analysis with a kind of rule. There are specific rules available to doing that. And as a third piece, the 3D inspection, 3D inspection itself, and also the 3D inspection analyzer. And of course, other tools are also available in the inspection tools in RealWorks, the annotations, the alignment, stationing, and the 2D polyline inspection. Yeah, when we are talking about license, today we are covering the advanced edition for Trimble RealWorks. As you see here, mainly covered all these features that I will talk in details in a minute. Then what else? It's coming with advanced edition. You can also do the data registration, like using the targets or bundle adjustment, georeferencing, and all the 2D and 3D deliverables can be used with the advanced edition in RealWorks. On the other hand side, also the advanced registration is available, like the targetless registration, the auto register using planes, the refinement, the station setup, and the import and registration wizard if you're using FLS files. Also the advanced 3D deliverables and inspection that I'm talking now are also available over here. So it's a quite powerful licensing edition. Before we start, general workflow, of course, as you might know, we are going out in the field doing the data collection. Then you can go into the office and using RealWorks to create your deliverables or you processing your data. And this can be done with RealWorks. First step, of course, try to get the point cloud registered by using these features, doing a data cleanup with some of the features like sampling, segmentation, cloud-based classification or kind of rendering, and a few of these production tools like drawing, surface, imaging, and we are mainly covering the inspection tools in our session today. And of course, other features are also available in RealWorks like the Real Color, Scan Color, the Publisher, the Send to SketchUp, and the AutoCAD features. Yeah, let's jump into the inspection tool. As you see here on the top slide, I pull out the inspection tools. So we are going from the left-hand side, not really from the left, but starting with the annotation over here, what it means and how you can actually use in RealWorks. So the annotation has been included since the version 11.2, where we released also the Trimble X7 with Trimble Perspective. So the annotations are actually coming from Trimble Perspective. It's a quite handy feature in RealWorks, where you can pick a 3D location and mark it in the point cloud and adding images to it. It's quite useful feature if you would like to document your work a bit more for your customers. So here on the right hand side, this is the tool, how it looks like. In a minute, we will also jump into a short movie where I can give you a short overview how it looks like. In the workspace, you are getting the annotation tab. That's new. If you haven't touched the annotations yet. And below you will see this pins listed over here, or the annotations that are in your project. Good, let's jump into the RealWorks software. You see here under the inspection tab, we have the annotations. On the right-hand side, you can pick a point from the point cloud. You can give it a name. In my example, I'm providing a name like fence number 2, short description if you want, and you can also add an image to that pin. Once you hit create, on the left-hand side, where's the workspace listed, you see the annotation tab is listed, and also below a new entry has been created. What else you can actually do? You can actually choose a different color with the pin to just highlight a few things. When you right-click, there are more options available, like show the label over here. So we have the name, and if you extend this label, you also have the description on it. And you see if you're spinning around this the pin in the point cloud, the label is also spinning around. So you can also lock it on the left-hand side or right-hand side of the screen, so you can still spin around the point cloud, and you actually get more out of your point cloud with more details. For example, like I show here, you can actually add a few more images to it, and so this kind of stuff you can actually create a screen snap out of it and send it over to the customer if you want. So quite nice and handy tool. Another inspection feature would be alignment stationing. Here we have the option to split the alignment into a 2D step, or we can also do it in a 3D step from the path. How it looks like in RealWorks. So when we go into RealWorks, here in that example, I selected the alignment already. From normally in RealWorks, as you might know, you're going from the top to the bottom. So starting with the step number 1, with the reverse alignment button, you can actually reverse the alignment station. Then you can choose the options between horizontal distance and 3D distance. You can insert a beginning station, and you can add also a station prefix if you want. There's also another option to select, highlighting this over here. You can set interval start station if you want. So my example was 1.51, and you can also change the beginning station afterwards. The last option in that feature would be the interval, showing here. You can actually set any interval you want. Once you hit apply, on the left-hand side, you see there's a new object created, and this object can be exported in DWG or DXF if you would like, along with the label. The twin surface inspection is listed under the inspection map. So here we are using actually 2 surfaces. So what a surface means is either 2 point clouds that we are comparing with, or we have a point cloud and a mesh that we would like to compare, or as a third option, it's like 2 meshes that we are comparing. So once you're selecting the point cloud, this point cloud is your reference surface. It's normally highlighted in red, and the other one is the comparison surface. As a result, you're getting an inspection map, which can be analyzed afterwards. This is the tool, how it looks like when we look into details. So the defined projection is the first step that you have to select. And here we have different options like the cylinder-based projection and the tunnel-based projection. In my example, I use the plane-based. So I have here a data set where it's a construction site where the guys just trying to get the building done. So they had started a scan on Monday, and they came back on Tuesday, and they would like to compare these two point clouds to each other. When we're going back to our 3D view over here, as you see here, all the 4 point clouds are listed. So I'm selecting the first one and then the second one by pressing the control key on the laptop. Go into the inspection tool. Then on the right hand side, we choose the plane-based projection, and we have different options to define this projection plane. Here you see the perpendicular to the screen, or by picking 3 points, for example. It's really up to your project or point cloud that you're comparing with. In my case, I will use the Z-axis as a plane-based projection. Left-hand side, there's the scroll bar. You can scroll it up or down to actually move this plane in the Z-axis. As a second step, you have the resolution. You can actually pick any resolution you want. So I just selected 1 meter. On the third step, I picked the fill halls. It will actually fill out the halls where there are no data set available. And see below, you're getting the inspection map immediately. So once you hit create, on the left-hand side, you're getting the inspection map. So this one you can actually use afterwards, or you can hit this inspection map analyzer button to start the analyzing tool. Also, you can also go to the inspection map and hit inspection map analyzer. Here you have different options available. I will cover this in more details afterwards. Point and polylines, starting with that for that example. When we here have our inspection map listed, it's logged in 2D on the top, and we can actually pick a point, for example, and highlighting this point and adding a comment, for example, like point on the top. If you would like to have it, you can also pick from which surface you would like to have these points listed. So in my case, I will select the comparison surface to highlight this. You can hit create. This will create a 3D point on the left-hand side, and you can also select the polyline. You can also add a comment like area to check, for example, and hit create. Then this will create a polyline on the left-hand side. When we're going back to our 3D view, hiding the inspection map, you see actually the point cloud and our polyline plus the 3D point listed in the 3D view. So the point and the polyline can also be exported into AutoCAD or any other software solution. Another option I just want to mention here is that you can actually compare a point cloud to a mesh. As you see here, we have a tunnel, and we can actually compare the mesh to the point cloud. So RealWorks is always using the mesh as a reference, and the point cloud is a comparison surface. Another option in the inspection map is the surface to model inspection. There we also creating an inspection map between a surface and a geometry. Surface might be a mesh or a point cloud, and the geometry might be a plane, a cylinder, or a tunnel shape defined by 2 polylines, means a 2D shape, and an alignment path. So the last example, I will give you a nice data set. Over here on the right hand side, you see the point cloud, the 2D shape of the tunnel, and the alignment path through the tunnel. So with the next video, I walk through these steps, how it looks like. So you have to select all these 3 objects, means 2D shape and the alignment plus the point cloud, to enter these surface to model inspection. Then RealWorks is using these 2 information about the 3D path and the 2D shape to create this tunnel object. And on the step number 2, you can actually, along the path, you can set a resolution. Like in my example, I'm putting 1 meter, and for the 2D shape, also 1 meter. You can hit preview and see what RealWorks is actually doing. So I was enabling the fill holes in that example. That takes a while. And what you're getting on top is the inspection map. And you can also disable or enable the point cloud or the model if you would like. On the below screen, you can actually see that. And you hit create, as will create an inspection map on the left-hand side. And here, from there, you can also run this inspection map analyzer if you would like. This is now what we're doing here. So by default, it's open up the section and the shifts, which are quite useful. In that case, you see lots of windows coming up. This plowing trot on the right-hand side, this 2D slice, which are going through the tunnel. And you see here the red and the green line. So red means our reference, means the 2D shape and the alignment, and green means the point cloud. When you're scrolling on the inspection map on the top, you can actually see the elevation difference. It's highlighted also in the color on the color bar. You can also, on step 3, we can edit multiple slides. So every 2 meters, we would like to have a slide available into this model. So if these slides will be created once we hit create all. You see here this purple line, it means that is the position where we are at the moment. And we can also export these sections to AutoCAD. So give it a name, hit save, and then this vertical slide export parameters are open up. You can select the unit if you would like and hit export. That's it. When you create all, on the left-hand side, you're getting a few groups. We have the map sections like the reference, the comparison, and inspection. So these features can be enabled anytime if you would like. So we say yes. It creates another inspection map on the left-hand side. So we close the tool. And then on the left-hand side, when we look a bit more in details, we have this inspection map listed over here. Disable this one, and we enable this one by selecting all and hit display geometry. When you click right on your mouse, and you see here we have now all the slices visible in RealWorks. Yeah, that's a pretty nice feature. And what else we have? So we also have a few movies available on our YouTube channel. So one of the movies I picked has been generated by our product manager, Jason Hayes. I would like to share that with you right now. So give me a second to actually give it a try. Hope you can see it. Yeah, let's give you another idea how you can actually use these inspection map for the surface to model.
Hi everyone, Jason Hayes here, Product Manager for Trimble RealWorks. And in today's video, we're going to take a look at how to use the inspection tools to help you evaluate the verticality and flatness of objects such as walls. So let's get started. Okay, so what I've got here is just a short scan of a small area of a building. Now I've already run auto classification on here, so the software's separated the walls and the floors and the ceiling. Now what I want to do is I just want to come over here and I'm just going to hide everything except for the walls. So now I can just see these walls here, And then let's say we want to do an inspection to check the verticality or plumbness of a specific wall. Now in this case, let's take a look at this one right here. Now what I want to do is I'm just going to turn on the station so I can see where the stations were in relation to the wall. And what some people like to do when they do modeling or inspection is they like to go through and just isolate a specific station. This is going to help to eliminate any problems that you may have from registration. Now, it's not always required, not everybody does it, but just in case, this is how you do it. So I can see this is from station 4. I'm just going to select the point cloud walls. Then I'm going to go to my edit tab. Then I'm going to come over here to the sampling tab. Once in the sampling tool, I'm going to choose the option of scan-based sampling. I'm just going to click the light bulb up here at the top for the project and hide everything. And then I'm just going to turn on the light bulb for the station 4. Then I just need to click create. Go ahead and close the tool. And then I can also come in and hide these station markers because I don't need those anymore. Alright, next I'm just going to zoom in here and I'm just going to change my station color rendering to intensity based. This is going to help me identify the wall from the molding or any other objects that may be on the wall. I'm just going to select the point cloud, and then I'm going to open the segmentation tool, and I'm just going to fence right inside here, avoiding that molding around the wall. Okay, I'm just double clicking to end the fence, and then I'm just going to click this green check mark or the I button on my keyboard to keep that area in. Now there's a few more objects I'd like to remove. Looks like some sort of a room name tag and maybe a thermostat. So I'm just going to come over here, use my box selection, do that, click O for out, and do the same thing over here. Okay, so I'm just going to go ahead and click create, close the tool, and now I have this new cleaned up point cloud just of the wall. So you can see it's got a default name. I'm just going to name it wall inspect. Okay, that's good. So I know what that is. Then I'm just going to make a copy of that. I'm just going to use Control C, and then you can also do paste. Now I've got this copy. I'm going to take this copy now, and if you have the modeling edition of Trimble RealWorks, you can go up to the modeling tab, then choose cloud-based modeler. And I'm choosing cloud-based modeler because I want to fit the model to the point cloud. So then I want to choose actually the segmentation tool is already open. If it wasn't, I could just choose it from over here. And then I'm just going to segment along the bottom here. Oops. Use the polygonal selection. I'm just going to go around here like this. Double click. Keep that in. Now I'm selecting along the bottom of the wall because that's where I'm going to fit this model. Because in theory it should be the best at the bottom. Then I'm going to use a constraint. Then I'm going to use the constraint to make parallel. And once this option comes up, I'm going to make it parallel to a direction, and that direction is going to be the Z-axis. Now this is assuming that your scanner was level when you did the scan, or that you've used the auto leveling in RealWorks to try to level the scans up to the walls. Then I'm just going to click the green check mark to validate that space. Then I'm going to go ahead and click fit. Okay, so it looks like a good fit there. Then I'm just going to go ahead and click create, close that tool. Then I'm just going to select that plane, come up here to the plane bounding tool. I'm just going to move my mouse along here till I see this little kind of hourglass looking shape, and I'm just going to grab that and extrude this plane up to the top. And I might bump it over here on the side as well. Okay, move that over there. Okay, that looks good. Go ahead and click validate. Alright, so now I've got a nice plane fit to the point cloud, but I actually only fit it to the bottom of the wall, and then I extruded it up to the top so that I can use it for comparison. Then I'm going to come over here and select my new plane. Then I'm going to use that point cloud that I named wall inspection, selecting both objects. Then I'm going to come up here to the inspection tab, and I'm going to open the surface to model inspection tool. Now you have to have at least 2 objects selected to open this tool. You can see if I just have one selected, it's still grayed out. So again, I want to make sure I have both of these selected, and I'm just going to open the tool. Okay, now what I'm going to do in this surface to model inspection is I'm going to compare this plane to the point cloud, and I need to set a resolution. Now, I want to set this resolution small enough so that when I take measurements, they're going to be accurate. So if I had a resolution of 1/2 inch, none of my measurements are going to be any more accurate than 1/2 inch. But I don't want the resolution set smaller than my point cloud spacing. So I'm just going to use the measurement tool up here, and I'm just going to zoom in. Now this point spacing isn't going to be great. This was just a 30-second scan I think I did with the TX8. Pick these 2 points here. And so this spacing is about 8 millimeters. Over here it's about 6 millimeters. Okay, so I know that I don't really want to go too much smaller than that. So this, if I go ahead and type in 0.25 IN for inches, you can see it's going to be about 6.3 millimeters. So that works out. Then I'm just going to come down here to the step 2, and I'm going to click on preview. Now you'll see there's this fill holes option. I'm just going to turn that off for now. Click preview. So I've got a pretty good inspection map. Now there's different colors showing the differences between the plane and the point cloud. You see these black areas are where there's no points, so there's nothing to compare to. And you can see there's a few black areas up here. If I click on the fill holes and then do a preview, it's going to do some interpolation to try to fill those areas in, so it gives you a little bit nicer look. Now as I look at this, I have a color bar over here on the right. So the darker colors are where it's going to be deviating the most. So the darker blue, you can see it's down here around 4.5 millimeters. Up here at the dark red, it's about 8 millimeters. And also, as I move my mouse over the inspection map here, you can see the differences. So here we've got about 1 millimeter, and up here you can see it's up to around 2, 4, depending on where I click. Now another thing that you can do is you can come over here and change the color bar to be a cut or fill color bar. I find this a little bit more useful when I'm working with these kind of vertical surfaces. Now it's either going to be red or blue. Darker blue is more it's deviating, and the darker red is more it's deviating in the other direction. Where the color is almost white or a very light red or light blue, that's where the wall, the point cloud, is matching very closely to the plane. So again, as I move down here in this kind of blue area, you can see that it's about 1 to 2 millimeters. As I get over here in these really dark regions, you can get it. See, it's getting up to around 4, 6, somewhere is going to be around 8 millimeters. Okay, so then I'm just going to come over here and click on create. You can already see quite a bit going on with our point cloud. Just going to close the inspection map analyzer. Let's just hide all of these objects and then just turn on the plane and the wall inspection. So you can see down here, I can see the plane through the point cloud. That lets me know that the plane's closer to this side. Now up here at the top, I can see the point cloud a lot better than the plane. That lets me know that the wall is leaning out toward me at the top because the point cloud is on this side of the plane. If I come back down here and turn on my inspection station, just go ahead and hide my point cloud and my wall, I can see anywhere that it's red, that's where the wall is leaning toward me. Where it's a blue, that's where the wall is maybe a little bit the other side of the plane. And then again, where it's white, it's where it's matching very well. You can see down here where I took my sample, that's where it's fitting very well. Now if I want to, I can open the inspection map analyzer by selecting the inspection map, then come up here to the inspection tab, click on inspection map analyzer, and I can do some more analysis on here. One thing that's pretty useful is to use this points and polylines option. Then I can create a point or draw a line, and I can pick which surface to put it on. By default, the software is going to use the model that I created as the reference, and then the point cloud is going to be the comparison. Now in this case, I just want to draw on the comparison because that's going to be the point cloud. That's the real life what's going on. Now I could come over here and create a point somewhere, or I could even draw a CAD line. So let's say we want to draw a CAD line around this area here where we've got the kind of the worst deviations going on. Something kind of like this. Just double click to end the line, and then just scroll down here, click create. I'm just going to close the tool. Now as I look over here, I can see my inspection map there. If I hide the inspection map and just turn on the point cloud of the wall, make those pixels a little smaller. Now I can see the CAD line showing me right where the deformation is on there. And if I want to turn on the rest of the walls, you can see how it looks in relation to everything else. Okay, so that's pretty much it. Now if I wanted to export that out, I could just come down here and select that point line, go to the home, and then export selection to send that polyline out as a CAD object. Now in addition, I can also select the inspection map, which you see right here. I can select the inspection map and come up here to the export and choose export inspection map. In that case, it's going to send it out as a GeoTIFF that you can open in many CAD packages. So that's pretty much it, a quick and easy way to go through and evaluate the verticality or plumbness of objects such as walls. Now the tool can be used for anything. It doesn't have to be a vertical wall. You could even go through and evaluate the flatness of an object such as a floor.
Yeah, that's the video that I want to show you. Let's jump back to my presentation. It was giving you a good example how it looks like when we going a bit more details, how the inspection map works or what kind of features are available. So we have, as you have seen, the points and the polylines as an option, and then we have a colored mesh option that you can select from the inspection map analyzer. Then we have the sections and shifts available. Volumes and surfaces are available, and as the last feature, the ISO curves. The next few slides, I want to show you a few more details, how it looks like. So the points and polylines, as you have seen in the YouTube movie from Jason, it's a very great feature. So in my example here, I had a sand pit where I compared the 2 point clouds to each other. I selected already, created already inspection map, and from that inspection map, I can go into that and select the points and polylines on the right hand side. So here we have the tools available. Also the plot section are available. On the left hand side you have a cursor. You can scroll it up and down in the horizontal direction. And yeah, on the right hand side, the surface you want to select. Here are the objects available, and we adding a point, for example, on the top. As you see here, it will create a point already with the coordinates. You can add a comment if you would like, and hit create. So we are doing the same for another point over here on the right hand side, a bit lower. For example, over here, create a point, give it a name, point number 3, for example, and hit create. So when we also want to have a point on our reference surface, we can still select on the inspection map on the left hand side, pick a point and give another comment to that, point number 4. We can also do this with the polyline, of course, as you have seen in the previous movie. We can hide these ones, and we can also go to draw a polyline, for example, on the top. So this polyline will be then placed on the reference surface, means the bottom. This is how it looks like. When you untick the lock in 2D, when you hit create, it will create a polyline on the left hand side. You can close the tool in a minute. You can also see this inspection map. You can also display it. And from here, you can actually see that we have the inspection map. We have these objects available, which can be exported, and this is quite useful for you or for your customer. Another nice feature is this color mesh inside the inspection map analyzer. Just to add on, you also have here the scroll bar and the vertical. You can actually define either horizontal or vertical, so which direction you would like to use these sliders. When you go to the colored mesh, it will actually create a surface from your reference surface, for example, this one. And when you hit create, on the left-hand side, you're getting this mesh object created. Or you can also select the comparison surface on the right-hand side. You can hit preview to see it. Give you a mesh property values like the number of verticals and triangles, and you can hit create. It will also create a mesh on the left-hand side. Another option would be the sections and shifts are quite useful. Here you see actually the sliders, vertical or horizontal, as I mentioned before. You can move it to the left or to the right. We will can also pick a point if you would like, if you have an interesting one. And we have these objects that we can hide or display, like the reference section, the comparison section, or the 1D inspection. Then as a step number 3, you have this multiple slides available where you can actually create multiple slides through it. We have here this next button. You can actually go through these slides. This option like reverse direction, it will actually go in the other direction. So this purple selection gives you always indication where you are at the moment. Quite powerful feature is this color bar. We have different color bars set it up, as you see here, from the lowest value to the highest, like always more or less positive values over here. You can also scroll it on the left-hand side. So when we go to the color bar in a minute, you see here we can set back to our default color bar, or we can actually edit the color bar. You can give it a name if you would like for example, my scale bar in my example, and we can actually define the color level steps. For example, 1 meter, how many colors we would like to use, like 10, for example, and we can also export these color bars to a text file. We can also define the color itself by the advanced editing. So the color, what you want to display, you can actually set up for your needs. So you can really customize the color bar up what you want. This is a very powerful feature. You can export this, import back again. So really to highlight what kind of information need to be transferred to the customer. Step number 4 provides you also the export sections. As I mentioned before, we hit save. You can actually see this horizontal slices are selected. You can get these features available over here, and this will create DXF files, DWG files. On the left-hand side, you get these folders on the left. You can always display this. When you enable the point cloud and the sections over here, the geometry, we can actually see that. So quite nice and helpful tool. Another one would be the volume and surfaces. That's also available in the inspection map analyzer. Here we can actually draw a polyline over here, for example, on the top. It gives us this square meters and the volume out of it. We can add more if you would like, for example, by adding this one, or we can remove something from the existing one, like edit over here, or we can do also an intersect of the polyline selection. And you can hit report to give you a report out of it. The same for the color. You see on the left-hand side, it's more like the pixels color map, let's say. We can also select different colors, and we can add different colors to it to really get the volume and the surface out of it, if you are interested in it. And the same, you can also reduce this. The button on the right-hand side is always going back to the default setting. We have here also a color range definition, but I'm talking in detail in a minute. When you go here to that selection, surface values you can actually define above a certain surface. For example, on the horizontal slides or vertical 100 square meters, it's actually that area, and you can actually provide you this feedback. You can hit report. It always gives you these values, the cut and fill values, the areas that positive or negative, and you can save that file into a kind of Word document. Another nice feature is the ISO curves, which are available in a section map analyzer. When you go into that, you can actually hit preview, and you see actually you're going through these curves. Here as a reference, you can put a reference, define parameters, you can set an interval, and if you're selecting the defined principal EO curves, it will actually label these curves for you. So I would like to label this every 5 steps. So starting with 0, 2.5 meters, 5, and so on. This is all in 2D. So when you create all, on the left-hand side, you get this group folder created for you in RealWorks. When we disable the geometry, you will see that's all listed in 2D. If there's a question coming up about the contour lines, of course, contour lines are also available in RealWorks. That's available under the Surface tab. When we're going further about the export feature, what's available. So if you're selecting the inspection map analyzer, you can always export this into different options. We have this vertical slides, horizontal slides, and the inspection map itself. So the inspection map comes as a TIFF file in the end. So we have here a few parameters. We also have these on intervals, the horizontal interval, the vertical, and the application factor. The factor is actually representing the elevation, which is actually displayed. And yeah, the application factor here, that's a factor used by the difference in the elevation when they are too small of the viewing. You can set this up. When we jump into the floor inspection, so we have this floor inspection in general, where we have on the top the first selection, like a manual segmentation feature, or the sampling is a kind of automatic process where we extracting the point cloud based on certain categories. For example, the ground extraction, that's more used for outdoor classification, or for the floor extraction, it would be more used for indoor. As a result, if you are exporting the floor inspection, it gives you a report, RTF format. It can look like this. And you also give you a JPEG file with all the points are displayed either in yellow or in white color that are exported. So points which are in gray color are actually not exported as inside a text file. So they are more used when you're using this out of tolerance feature, which I will show you in a minute. Another feature that you are getting out for this export is the TIFF file format. It's like, for example, this one over here on the right-hand side, there's a color bar. And the text file where all this cross were available, or the text file is more related to this TIFF file format. So it's giving you the coordinates of the 4 corners of this TIFF file. You can actually use it for any other office softwares that are handling these kind of georeferenced TIFF files. And in the end, you're getting these point text files where all these crosses are available with the color information. How it looks like in RealWorks. When we jump into RealWorks, we have this example data set over here. A nice floor has been scanned over here. I had done already the segmentation for you over here. And when we're going to this segmentation, You see here there are still a few points which are not really interested for our floor inspection. So you can either go to the auto classification tool by hitting ground and hit extract, or you can go to the sampling feature. On the right hand side, you can also select the ground extraction, which gives you the same result. I did this already, so I'm enabling this point cloud over here. You see here now we have a nice and smooth floor. You go into the inspection map to the floor inspection itself. And on the right hand side, you're also getting on the top these two features that I just show you. So there's actually no need to go to the certain tabs. So you can also open up the floor inspection and use these two sampling and segmentation tools from the top. And step number one, we are defining a grid that we want to investigate further, the area. So we have this grid spacing that we are using, and where this step number two, where the reference plane is located. So we can also display the point cloud or hide the point cloud, the same for the inspection map. And as a result, when you hit export, you're getting these different objects available. So we call it floor inspection. When you hit save, it will open up the Word file for you directly with the report that is providing you more details about the floor inspection. So over here, we're getting the volume and the area, and we are getting this nice TIFF file. When we open up the Explorer, it's actually giving us certain object, as I mentioned, this JPEG file over here with the cross and the difference, so the point numbers and the difference to the, what's the difference in elevation. Related to that is this text file, which is all points are listed over here. And we are getting this TIFF file, which is not including these crosses. It's just the map itself and these text files related to this TIFF file, like the corners of the TIFF file. When we hit create, it will create a group on the left-hand side, an inspection group. You go in, you have this inspection map over here, and we have these grid for the floor. Good. As the next step, I want to mention the floor flatness and the floor levelness analysis. There's a certain standard available called ASTM E1155. So there's a standard available where a person in the past had set it up, and it's quite useful and used in the industry. So what are the rules over here? There are certain constraints available for using this floor flatness and floor levelness. So we have specific analysis available to doing this for floors. We need to have enough density. So as a minimum, we need to require one point at around 10 millimeters, but we are recommending 1 point at around per millimeter. The minimum dimension would be 2.44 meters for both sizes on the selected area, and the surface area should be higher than around 30 square meters. When you're creating the examples, the samples, there are two options available. So one option would be the orthogonal or parallel samples. On the right-hand side, it's a short creation. So we are starting with one click and going on the orthogonal to the right. So the length is also at least around 3 meters. The first sample cannot be longer than the shorted side of the section, and parallel samples should not be closer than 1.22 meters. So these are the rules along with these standards. Number of orthogonal and parallel samples should be equal. So we also have the same lines, and all samples should have the same length. Another option would be be in starting diagonal from that area. We have here two rules. At least 3.35 long should be one sample, and parallel should be not closer than 1.22 meters. If you're not following this, RealWorks giving you error messages, like if you're not holding the length, or for example, if you are too close to the samples, he also giving you an error message. And if you're selecting an area that doesn't cover enough point cloud data, it will also give you some warnings. Yeah, how it looks like in details, there's also a nice YouTube movie available on our YouTube channel, which I want to show you in a minute.
Hello everybody, Devin Martinez here, Product Manager for Trimble Geospatial Software. Today we're going to demonstrate a workflow utilizing our new Floor Flatness, Floor Levelness tool released with Trimble RealWorks version 10.4. A bit of background about this project. A local contractor had just poured a concrete slab. Based on their contract, they were required to perform a floor flatness, floor levelness test. This test was performed by a third party. Today we're going to demonstrate how to square up the cloud using the RealWorks orientation tool, clean up the cloud using the sampling and segmentation tools, and finally perform a floor flatness, floor levelness analysis and create a report that will fulfill the GC's contractual obligations. In the field, we used a TX8 scanner, and we scanned 4 times to cover the floor space in question. For improved registration results, I will generally only level the most central scan, and then disable compensator for the rest of the scans. This allows for the unleveled scans to have 6 degrees of freedom during the registration process. As you can see in the list pane on the left side of the screen, a leveled scan will be denoted by a blue folder. As you can see, I have sampled the TZF scans and fully registered this point cloud before this demonstration. For more information on those processes, please see the link in the description below. We will start by squaring up our point cloud relative to the XY coordinate system. The orientation tool can be found in the registration tab. Select the orientation tool. Within the orientation tool, we will define a horizontal axis by picking 2 points. This will define the x-axis. I'm going to select 2 points along the longest leg of available point cloud data. After I select my second point, the cloud moves, and I like to verify that I'm square with the gridded background. To permanently apply the transformation, click the green check mark and exit the tool. Now that we've squared up our cloud, we're going to begin the cloud cleanup process, such that we're left with a completely clean floor to perform our floor flatness, floor levelness analysis. In most practical cases, a test area is generally completely cleared before scanning, but in our case, the test area was occupied with workers. Begin by placing RealWorks into production mode. Notice by default, our project cloud is off. We will turn it on by simply clicking the light bulb in the list pane. I understand many people may prefer to use the segmentation and sampling tools inside the Edit tab, but today I'm going to use those tools directly inside of our floor flatness analysis tool. We'll start by pressing the Inspection tab, clicking our floor flatness floor analysis tool, And from here you can find our quick access segmentation and sampling tools. We'll start by selecting the segmentation tool to clip away all the unwanted point cloud data. Fencing in the area of interest. To close out the loop, we'll double click and select the check mark to keep point cloud data in. In the View tab, we'll go to the preset left view. Again, clipping away the unwanted data. Double click and keep point cloud data out. Exit the tool. And now you can see that we're getting close to having a completely clean floor. We've got a few columns left in place. For the final step in the cleanup process, we will select the sampling tool and use the floor extraction indoor tool to clean up the columns and the noise. Let's select show outliers and extract. Well, what this is doing is identifying all of the point cloud data that is not considered to be floor. And here you see it all highlighted in red. We'll select keep floor, and this will remove all the unwanted points in red. All we're left with is a clean floor surface. A clean floor surface is very important because any outliers will skew analysis results. Select Apply to return to the Floor Flatness Analysis tool. Now that we've cleaned our floor surface, we are ready to begin the floor flatness analysis. First, we will need to define our test area. Start by selecting Define. We are then prompted to begin drawing our test area. Start by selecting your first point. Notice the red line. The red line denotes that we are not able to draw a line that short based on the ASTM standards. It will turn green when the line is at appropriate length. After selecting our second point, we'll drag the box to the appropriate size. Again, it will turn green when we are at appropriate length based on ASTM standards. After our test area is defined, in the workspace, if we scroll to the bottom here, we can take a look at the minimum number of readings that we'll need. As many of you know, a reading will be taken every 12 inches along our single run. Now we will begin drawing our test runs. Press the Add Sample button. Based on ASTM standards, the first run needs to be along the 45 of your test area. Immediately, we see floor flatness and floor levelness results of the run. To add another sample, we will select the Add Sample button. To meet ASTM standards, we will be locked into drawing perpendicular lines crossing our main center line. When our line is long enough per the ASTM standard, the line will turn green. We will continue to add evenly spaced samples until the test area is completely covered. You can press A as a shortcut to add samples. Once finished, we can scroll to the bottom of our work screen to review results. Here you can see the overall floor flatness and floor levelness, and the minimum floor flatness and floor levelness of the test area, along with their 90% confidence ranges. A screenshot will be provided in your report. It will be derived from your active view, so please orient your view to a desired location before proceeding. To create the report, select the Report button. A quick reminder appears that the ASTM standards requires our samples to be uniformly distributed throughout our test area. Simply select Yes and choose a file save destination. We are then prompted to enter our contract specifications. In our case, our floor flatness SOV was 30. Our floor levelness SOV was 20. Our MLV for floor flatness was 18. And floor flatness SOV was 12. Select Create and a Word document is generated with our test results. At the top of this document, we are provided with project-specific details. As we scroll down, we start to see contract specifications. This is what we just punched in the last screen. Our test section area, along with the minimum number of readings and the readings we took, a screenshot of our test area, and here's where we will find the overall floor flatness and floor levelness results for our analysis. As we continue to scroll through our report, we will find individual results for each sample. And in our case, it looks like our floor is passed with flying colors.
Yeah, I hope this gives you an overview about the floor flatness and floor levelness. Let's jump back to my presentation as we are running a bit over time. What I want to cover as next 2 points are just the 3D inspection and the polyline inspection. When we click quickly, the 3D inspection, it's mainly used for to compare 2 point clouds to each other. The difference to the surface twin surface inspection is that the 3D inspection does not use the protection itself. It's using the 2 point clouds in comparison the distance between the points. As a result, you're getting a 3D inspection cloud, which can be used to export, for example, to E57. And the color information for that point cloud will be replaced by the true color. When you're looking in more details about the 3D inspection, we can select 2 point clouds over here. The first one is always our reference. We then have a few options in the 3D inspection. We still have these nice features like the segmentation and the sampling feature that we are cutting out our point cloud of interest in that example. Then we can hit compute and it's give us a colorized point cloud from -230 to +230. We can also define a maximal distance, for example, 3 meters, that's ±3 meters. And we can also do an absolute distance, that's where all the point clouds are in positive values. When you hit create, you get the 3D inspection cloud itself, like this color ones, and this point cloud can be also exported. When we have this 3D inspection cloud created, you can use the 3D inspection analyzer by simply selecting this one. And as I mentioned, this 3D inspection cloud can be exported to E57. Here's an example about the export feature. So if you're selecting these clouds, you can actually replace the inspection color by the true color. This is an example of that. And when we're looking closer into the 3D inspection analyzer, go ahead and selecting the 3D inspection cloud, click 3D inspection analyzer, and on the right hand side, you getting this color bar over here. So from 0 to 2.60, we have the colors. We can define, let's say it should only display the points from 0 to 1.5. You see here this black, and it's the area where the 3D inspection analyzer will cut out the point cloud. We can hit extract. So this will be cut out, and once you're hitting create on the bottom, it will create a cloud object for you. So quite useful tool. We can also do a bit more on that. When you going back to that point, you can also select from 0.5 meter or from meter to 1.5 meter if this is the interest that you are looking for, and hit extract. It will only provide you the points where in this certain range, and you can hit create. It will also create a cloud object for you. As a last step, I want to mention the 2D polyline inspection. It's like what we have in the inspection map analyzer, like the sections available. It's one of the first features that we had in the inspection tool over here. It's quite straightforward. Maybe going to that movie over here, we have our sandpit. We created already object like alignment, and from that alignment we can do a 2D polyline inspection. We are selecting one of these alignments, for example, and it gives us the vertical information to the point cloud on the top. See here, over here, and you can also define certain distances. So 7.1 is always the distance, so 1.2, whatever, and you can then specify only these parts you want to select. You can also hit create, and it will create these inspection object to the left. So this one can be also exported. Yeah, that's it almost from the inspection map. So what is next? So once you have the data processed and analyzed, what's next? Of course, you can create other deliverables out of Trimble RealWorks. You can also export certain types of inspection or dataset that you had created during the process, or you can also use the Trimble RealWorks publisher. If you're not aware of, the Trimble RealWorks publisher is a great tool to share your data or what you have done with the customer. So there are a few steps you can actually add. You can add a logo, or you can also do adding some images like JPEG, GIF, or whatever, and also add some videos what you have done or how it looks like, and certain links you can also add to that publisher, as you might know. Yeah, as last slide, just mention a few resources where you can find additional information about RealWorks, which is a quite powerful software solution. So our YouTube channel, it's really recommending to visiting this over here. There are more videos available. Our online community, where you can find more information about RealWorks and interact with other RealWorks users. Of course, the RealWorks help guide by pressing F1 on your keyboard, and the user guide itself. And I'm also listing here the latest RealWorks version 11.2. Yeah, that's it from my side. Ronald, if there are any questions in the chat, please let me know.
Yeah, there were a couple of questions. One of the questions was, you mentioned the publisher tool before, whether you can export mesh maps in the publisher tool.
Not directly. Actually, we have to create some images out of it. It's more like a documentation tool, the publisher. So if you are creating a project, it's actually getting out from the TCF file. So all the objects that you have done inside RealWorks are not getting into the publisher, not at the moment. So what you have to do is more like using the images or videos describing what you have done.
Mm-hmm. Okay, thanks. Can we change the scale of the map on the floor inspection as well as the color?
The scale itself, you can change, yeah, under the preferences. There are options available. You can change that, yes.
Okay. And can I use an alignment for the surface to model inspection 2D or 3D path?
Yes, you can actually use that, but you also need to have this 2D shape along with that. So alignment, it's you always need to have these, let's say, template and then the alignment to it, and then you can compare it to the point cloud.
Yeah. That was it all for now on the questions. There were a couple of questions on people asking about whether there's also a recording available. Everyone who has signed up for the webinar will actually get an email with a link to to the recording, and on our webinar webpage on geospatial.trimble.com, you also can find all the recorded the past webinars that we have done. So that's another way to look at them. And other than that, Stephen, thanks very much for a very informative webinar.
Yeah, you're welcome. Thanks a lot. Thanks for watching, and hope to see you soon, guys.
Thanks, everyone. Thanks for your time. Thanks.
Thanks. Bye-bye.